Hey, ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 2, Notes 6. That should actually say not Notes 5, Notes 6. And we are going to be talking about proving lines are parallel. So there is going to be a decent amount of writing today, and you do want to write these theorems in because you can use them on your quizzes, and that way you don't have to try and remember what each of them means. So the first one that we are going to talk about is the converse of corresponding angles postulate. So if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So what does that mean for us? So for example, if it tells me that angle 1 is congruent to angle 3, then A is parallel to B. Okay? We also could have said if angle 2 was congruent to angle 4. These are all corresponding angles. So basically, if any given corresponding angle is congruent, then the lines are parallel. Likewise, if angle 8 is congruent to angle 6, and so forth, you can continue to name all of those congruent pairs. Okay, then we know that the two lines are parallel. So that's all that the converse of corresponding angles postulate means. So let's take a look at an example of this, okay? So given the following information, is it possible to prove that the lines are parallel? If so, state the postulate or theorem that justifies your answer. It gives us that 1 and 3 are congruent. So what I notice is that 1 and 3 are corresponding angles. So since they're corresponding angles, then yes, they are. So what we're going to say it's true by is that they are parallel by the corresponding angles converse. Okay? Corresponding angles converse. And a lot of times when you're doing this, you'll actually say, okay, A is parallel to B by the corresponding angles converse. So that's the theorem that I just typed that it's going to be. Let's take a look at our next postulate. So if a given line and a point not on the line, then there exists an exactly one line through that point that is parallel to the given line. So that would be this guy right here. So this line that I just drew is the only line that is parallel to M and still goes through point P. So there's only going to be one of those. Okay? So now let's take a look at some other theorems. Again, I can talk a lot faster than you can write, so make sure you're taking the time to pause the video if need be, okay? So if two lines in a plane are cut by a transversal so that the pair of alternate exterior angles is congruent, then the two lines are parallel. So what we're looking at here is they're saying, okay, 1 is and 3. So if angle 1 is congruent to angle 3, then, I'll just use a T, P is parallel to Q. Okay? So that's what alternate exterior angles converse means. So let's go ahead and let's take a look at consecutive interior angles converse. So if two lines of any plane are cut by a transversal so that a pair of consecutive exterior angles is supplementary, remember that supplementary means that it adds to 180 degrees, okay, then the lines are parallel. So if it's given to us that angle 4 plus angle 5 is equal to 180, if that's given to us, then we know that P is parallel to Q. Okay, so that's all that that one means. Now let's take a look at this alternate interior angles converse. If two lines in a plane are cut by a transversal so that a pair of alternate angles is congruent, alternate interior angles are congruent, then the lines are parallel. So if we know that angle 6 is congruent to angle 8, then we can say that P is parallel to Q. Okay, that's if it's given to us that these two are equal, then we know that we have two parallel lines. Taking a look at this, perpendicular transversal converse. In a plane, if two lines are perpendicular to the same line, then they are parallel. So looking over here, we know that R is perpendicular to P, and also that R is perpendicular to Q. Remember that upside down T means perpendicular. So then we know that P has to be parallel to Q, because you can't be perpendicular to the same line and not be parallel. That's kind of what this theorem is telling us. So now what we're going to do is we're going to go ahead and we're going to apply some of these. So for this first one, it gives us that 1 is congruent to 6. So how are those two related? Well, they're alternate exterior angles. So then what we know is that the line that's related with 1, which is L, and the line that's related to N, or to 6, which is N, so L is parallel to N, and then that is going to be by the alternate exterior angle theorem, or converse, sorry. Okay, so that's going to be true by the alternate exterior angle converse. So now let's take a look at this next one. So angle 2 and angle 3 are congruent. Now those two lines are related to line L and line M. So we can say that line L is parallel to line M. And since we're talking about alternate interior angles, they are going to be congruent to each other by the alternate interior angle converse. Okay, so the alternate, wow, if I could spell, that would be awesome. Alternate interior angle converse for that one. Okay, so now let's go ahead and let's take a look at the next one. So for the next one, it gives us that 2 and 8 are congruent to each other. So let's go ahead and highlight 2 and 8. So 2 and 8 are related to angle A and angle B, where L is the transversal cutting through them. So for this one, I can say that line A is parallel to line B, and 2 and 8 are alternate interior angles of that line. So that's what we're going to put, alternate interior angles converse for that one. Okay, so now let's go ahead and let's take a look at 3 and 11. So I have 3 here and 11 here. So what I notice is that relates angles L and angles M, where A is my transversal. So first of all, I'm trying to prove that line L is congruent to line M, or parallel. Okay, and I noticed that 3 and 11 are corresponding angles. So that's actually going to flip over to our very first page of notes. And so that's going to be the converse of corresponding angles postulate. So that's what proves that to be true. Okay, the converse of the corresponding angles postulate. Now, let's go ahead and let's take a look at 1 and 15. So here I have 1 and here I have 15. So we're trying to prove that A and B are going to be parallel to each other. So we're trying to show that A is parallel to B, because those are the two parallel lines that 1 and 15 are touching. So what I notice is that they are alternate exterior angles. So that's the postulate that I am going to use. So the theorem. So it's by alternate exterior angles converse. That's going to be my answer for number 6. Okay, so that's all of those 1 through 6 there. So now let's go ahead and let's put it into practice with some of these word problems. So for number 7, it says, in the ladder shown, each rung is perpendicular to the 2 rails. Is it possible to prove the 2 rails are parallel and that all of the rungs are parallel? If so, explain why not. So I'm noticing all of these right angles. Okay, and so if you recall, we did something with perpendicular lines, one of our theorems. It says that in a plane, if 2 lines are perpendicular to the same line, then they are parallel, which means that all of our rungs have to be parallel because they're all perpendicular to these lines, and likewise, all of our ladder steps have to be perpendicular because they are all perpendicular to that as well. So then what we're going to say is yes, because of the perpendicular, transversal, converse. Okay, so that's going to be true by the perpendicular, transversal, converse. So let's take a look at our last one on number 8. In order to move in a straight line with maximum efficiency, the rower's oars should be parallel. Refer to the photo. Is it possible to prove that any of the oars are parallel? If so, explain how. Well, let's go ahead and let's take a look at this. So this one right here is 110. Well, that forms a line with that angle right there. So 180 minus 110 is 70. So that angle right there is 70. This angle right here is 80. So in order to form a line, that means that that angle right there is 100. Now, in order for those oars to be parallel, our two interior angles need to add up to 180. And 70 plus 100 is not 180. So that is not going to be true. So we are going to say no because it does not uphold the consecutive interior angle converse. So since that's not true, then they can't be parallel, okay? So that's going to conclude your note video for today. Please let me know if you have any questions. Thank you for listening.